Hi guys, so welcome back to lesson 7. In this lesson, we are going to learn about stem and leaf flux. You can pause the video here so that you can write the heading for the lesson. The goal for today is we can construct and use stem and leaf flux to compare data. Okay, so to get you thinking, I found this picture of a train departure timetable in Japan, and I thought that it was quite interesting. Okay, so I want you to have a look at it and then think about, okay, so how can we read this timetable? Now, you may have noticed that this kind of looks like a stem and leaf flux and leaf flux, right? So the way that we would read this flux is that, say for example, this one here, so we have 10 and then 0. Okay, so we have a train departing at 10 o'clock, right on the dot there. Then you have 5 minutes past 10, then 7 minutes past 10, and so on, right? And from this graph, you can see that we can get a lot of information from the chart, from the plot. Okay, we can see here that between 7 o'clock, right, and all the way to almost 9 o'clock, we have we have quite a lot of trains. Okay, so that tells me that, hey, this is when people go to work, like in the morning, so there must be a lot of trains to carry people. Okay, and then also around from 5 o'clock to 7 o'clock in the evening here, again we have another peak, so that means that the number of trains has to increase to take people home from work, right? So here's a couple of notes that I would like you to write down. Okay, I will read through the notes, and if you need, you can pause the video to copy down the notes. So the first thing here is that in the stem and leaf flux, the last digit of a number makes the leaf, and the other digit makes the stem. Okay, so we only write the last digit for the leaf, and there needs to be a key to show people how to read the data. And I'll show you an example of a key in a moment. And then also you need to arrange the data in ascending order. Okay, so remember, ascending order means from smallest to largest. Okay, so here we have an example. Now I'm not going to make the whole stem and leaf flux because it does consume quite a bit of time. I'll show you how to do the first few, and then you can do the rest yourself. Okay, so consider this set of data. So we have all these numbers here, and I can see, first of all, is that we are dealing with decimal. Okay, and that's going to be important when we make our key in a moment. So question A, ask us to organize data into an ordered stem and leaf flux. Okay, so let's do that. So A, now we need to make the key so that people know, and also for us to know how we should read the data. Okay, so I'm just going to pick a random number here. I'm just going to pick this one here, right? 2.4. So I'm going to write 2/4, and this is going to be 2.4. Okay, so the slash here just takes the place of the decimal point. Okay, so this side is the stem, and this side is the leaf. And you can see here that only one digit. The last digit makes up the list. So we need a column for SEM and a column for the list. Okay. All right. Now, also, it may be a good idea to have a look at what is the smallest number. And from looking at these numbers here, I can see that 0.1 is the smallest number. So that means our SEM start with a 0. And the largest number, I can see from the data here, is 7.5. So our SEM will go all the way from 0 to 7. 0, 1, 2, 3, 4, 5, 6, and 7. Okay. So this is 0 point something, 1 point something, 2 point something, and then so on. Okay. All right. So like we said, the first one is 0.1. So I just need to write the last digit for the list. So 1. I'm going to cross it out because I'm done with it. I can see that there is another 0.1. So write another 1, cross it out. And then the next one is 0.3. So write the 3 and cross it out. Okay, so just the last digit. And then we move on. I don't think there is any more that start with 0. Yeah, there's nothing more that start with 0. So we move on to the ones that start, the numbers that start with 1. Okay, so you can see here there is a 1.0. So we write the 0. Oh, there is another 1.0. So another 0 there. Okay, and then we keep doing this for all these stems. Okay. Now I'm going to show you the answer because I don't want to waste your time. It will take a bit of time for us to finish the stem and list plot. So you would see, so here's the stem and list plot when we are done with it. Okay. So that is question A. Then for question B, it asks us to do the median, to find the median. Okay. And we can see here the answer is 3.35. Now let's work out how to get that median. Okay. So remember, for median, one of the important things that you need to do first is to arrange the numbers. Now, since we have already created a stem and list plot, that means that we have already arranged the numbers from smallest to largest. Okay, so that's really good. So we can use the stem and list plot here to help us. So the way that I would do this is I would count a small number and then a large number, right? So start from the smallest and the largest and then move into the middle. Okay, so 0.1, 7.5, 0.1, 6.8, 0.3, 6.3, 1.0, 5.8, and then so on, okay, until we get to the middle. So let me do it quickly. So when we get to the middle here, we can see that there are two middle numbers. So 3.3 and 3.4, okay? And remember, when we have two middle numbers, what we do is we would add these numbers and then divide it by 2, right? So this is what they've done here. They've added 3.3 and 3.4. That's going to give you 6.7. Then divide it by 2, and that's going to give the answer 3.35. Okay. Question C asks us to find the mode, and remember the mode is the most occurring number, and 4.1 occurs 3 times. Okay, and that's the most occurring number. And for D, asks us to describe data as symmetrical or skewed. And I can see here that the peak of this clock is somewhere in the middle. Now it's not exactly in the middle, but it's good enough. And then also the two sides are approximately the same, right? So we can say that this plot, that the data is symmetrical. Okay. Now also, we can use a back-to-back stem and lift plot to compare two sets of data. Okay. So what we have is the stem is in the middle, and then you have the lift on either side. Okay. Now, when we compare data, there are a few things that we can talk about. We can talk about the lowest on each side. So on the on the left-hand side here, 81 is the lowest number. On the right-hand side, we can say that 74 is the lowest. Okay, and of course, we can talk about the highest number as well. So on the right-hand side is 111. For the left-hand side is going to be 123, right? This one here, 1, 2, 3. And also we can talk about whether the data is symmetrical or skewed. Okay, so remember, skewed is when you have the data, the higher end is on one side of the graph. Okay, the peak is on one side of the graph. Now moving on to the next example here. So we've got two shops, and we have to draw a back-to-back stem and lift plot with an interval of 10. Now what that means is, well, we can see here that we have anywhere from 3 up to 28. Okay, so our key we can create for this is 2 plus 8, which means 28. Okay, and interval 10, so in the middle of our stem. Okay, so here we have the 1s, then we have the 10s, then we have the 20s. Okay, and then we just create the stem and lift plot. Now be mindful that when you create the stem and lift plot on the left hand side, okay, you have to sort of reverse how it would look normally. Okay, so you would start on the right and then fill out to the left. Okay, instead of writing from the left to the right. Okay, and for the comparison here, so the book says shop A has the highest number of daily sales. So again, we can compare the highest amount, and of course we can also compare the lowest amount. So shop A also has the lowest amount. We can also compare the general amount of sales here. So shop A, its sales are generally between 12 and 28, with 1 day of very low sales of 3. Shop B sales are generally between 4 and 17, with only 1 high sale day of 27. Okay, so shop B, the majority of the sale is in the 1s and the 10s. For shop A, the majority of the sales are in the 10s and the 20s. So we can say that shop A would be a better shop at selling the jeans. Okay. So remember, we can talk about the lowest number, the highest number, and the general distribution. Okay. So hopefully that helps you with exercise 9H here. And here are the questions that I would like you to do. Okay. I hope you learned something new. Okay. And thank you for coming in. I'll see you in the next lesson. Bye.